There is a boundary at the far edge of our solar system where the physics of the familiar slowly bleed out into something distinctly hostile. For centuries, when humanity looked up at the scattered diamonds of the night sky, we projected a comforting illusion onto the dark. We imagined the interstellar medium as a serene, frictionless ocean, a quiet, empty vacuum stretching outward into absolute infinity. We constructed our astrophysical models based on this intuitive assumption, believing that if a vessel could just sail far enough away from the warming, protective glow of our sun, the environment would simply fade into a peaceful, freezing nothingness. We were fundamentally, terrifyingly wrong. In the late summer of 1977, we launched a mechanical emissary to test those assumptions, Voyager 1. It is a delicate, primitive assembly of aluminum, silicon, and copper, sustained entirely by the decaying, radioactive heat of a plutonium heart, designed originally to photograph the turbulent storms of Jupiter and the rings of Saturn. It completed its primary mandate decades ago. Yet, long after its original purpose was fulfilled, the machine kept falling upward, hurling outward at an agonizing 38,000 miles per hour. It became the farthest human-made artifact in existence, a lonely, blind ghost ship navigating a lightless abyss. Today, at a staggering distance of more than 15 billion miles from Earth, our sun is no longer a source of warmth or planetary gravity. It has been reduced to just another pale, insignificant speck in a tapestry of overwhelming black. At this extreme operational range, the communication latency is a nightmare of orbital mechanics. It takes over 22 hours for a single, desperate radio command, traveling exactly at the speed of light, to cross the expanse to the probe. It takes another 22 hours for the faintest, degraded whisper of binary telemetry to return to the massive listening dishes of the deep space network here on Earth. Through that fragile, microscopic thread of connection, the engineers and physicists at the Jet Propulsion Laboratory waited for the inevitable end of an era. They waited for Voyager's aging magnetometers and plasma wave subsystems to confirm that the spacecraft had finally slipped into the quiet, undisturbed silence of the cosmic void. They expected the data to flatline, proving once and for all the vast, unbroken emptiness of deep space. Instead, the telemetry that trickled back across the solar system defied every baseline prediction. The instruments did not register a quiet, gentle fading of the solar wind. They registered a violent, catastrophic collision of cosmic forces out there in what was mathematically supposed to be the coldest, most desolate region imaginable. Voyager 1 did not find silence. It encountered a wall of fire, an invisible inferno of superheated plasma, fiercely pressurized and highly magnetized, boiling in the perpetual night. If you seek the truth hidden in the most unforgiving corners of the universe, subscribe and join us on this journey. To understand the sheer magnitude of the anomaly Voyager 1 encountered in the dark, we must first completely dismantle the way you intuitively understand the universe. We are planetary creatures, born and bound by the crushing weight of an atmosphere. Every physical interaction we experience is dictated by friction, by sound waves propagating through dense air, by the gravitational anchor of the Earth beneath our feet. Because of this localized bias, when we look up at the night sky, we project our terrestrial logic onto the cosmos. For the vast majority of human history, even into the modern era of astrophysics, we perceived space simply as the absence of things, a pristine, undisturbed vacuum. This comforting illusion of a tranquil, empty void is a lie. The space between the planets is not empty, and the space between the stars is infinitely more violent than our darkest terrestrial nightmares. To grasp what the edge of our solar system truly looks like, we have to look back at the origins of a fundamental scientific heresy. In the mid-20th century, the undisputed consensus among the world's leading astronomers was that the space surrounding our planet was a sterile, frictionless vacuum. They believed that the sun, while immensely powerful, was essentially just a static sphere of incandescent gas, radiating light and heat across the immense distances of a completely empty void. The planets were thought to be isolated islands, floating independently in the quiet dark. Then, in 1958, a young, virtually unknown astrophysicist named Eugene Parker submitted a paper to the Astrophysical Journal that threatened to tear this neat, orderly model to shreds. Parker had been mathematically studying the sun's corona, the ghostly, outermost layer of the solar atmosphere. The temperatures in the corona are an absolute paradox, burning at millions of degrees, vastly hotter than the surface of the sun itself. Parker's calculations revealed a terrifying reality. He realized that the sun's gravity, despite being the dominant force in our local cosmic neighborhood, was fundamentally insufficient to contain a gas that superheated. The math was cold, elegant, and inescapable. The sun could not hold onto its own atmosphere. Parker proposed that the star at the center of our solar system was continuously boiling away, violently expelling billions of tons of highly charged atomic particles, protons and electrons, stripped of their normal atomic structure, outward in every direction. He called this relentless, supersonic blast the solar wind. When Parker first presented this theory, it was met with overwhelming hostility. The reviewers at the scientific journals outright rejected his paper. The greatest minds in astrophysics told him his equations were flawed, his assumptions absurd. The idea that a hurricane of electrified plasma was tearing through the inner solar system at over 1 million miles an hour was considered science fiction. It took the launch of early Soviet and American probes, which physically flew into this invisible gale and registered the massive radiation, to vindicate him. Parker's discovery fundamentally changed the architecture of our existence. The sun is not a serene campfire warming us from a distance. It is an actively detonating thermonuclear engine, exhaling a hypervelocity storm of plasma that violently pushes against the fabric of deep space. This solar wind carves out an immense, invisible bubble in the interstellar medium. We call this bubble the heliosphere. Every planet, every asteroid, every comet, and every human being that has ever lived exists deep inside this protective, magnetic cocoon, sheltered from the true, unfiltered brutality of the wider galaxy. But a bubble, by its very physical definition, must have an edge. As the solar wind races outward past Mars, past the gas giants of Jupiter and Saturn, and into the frozen twilight of the Kuiper Belt, it begins to succumb to the merciless laws of geometry. The inverse square law dictates that as the plasma expands outward, spreading its energy over a spherical area that grows exponentially larger, it must become thinner, weaker, and more diffuse. The pressure drops, the wind loses its kinetic fury. For decades, the mathematical models predicting the nature of this outer boundary were surprisingly optimistic. The scientific community assumed that as the solar wind finally exhausted its momentum at the extreme limits of the solar system, it would simply fade away, a quiet, gentle surrender to the dark. They imagined it like a slow-moving river, softly bleeding into the vast, calm waters of a dark ocean. The transition from our solar system to interstellar space was supposed to be a seamless, peaceful graduation into silence. This brings us to the true nature of the space outside our heliosphere, the interstellar medium. It is crucial to understand that the space between the stars in the Milky Way galaxy is not a serene emptiness. It is a highly pressurized, turbulent graveyard of dead and dying stars. The interstellar medium is choked with the violent debris of ancient supernova cataclysmic explosions that ripped massive stars apart millions of years ago, sending shockwaves of compressed gas, heavy metals, and hyperaccelerated cosmic rays tearing through the galaxy. This galactic wind is a ferocious, highly magnetized soup of ionized radiation, sweeping through the spiral arms of the Milky Way. For billions of years, our heliosphere has acted like the hull of a submarine, pushing back against the immense, crushing pressure of this interstellar ocean. The boundary where the outbound solar wind finally collides with the inbound pressure of the galactic void is known as the heliopause. It is the absolute edge of our sun's jurisdiction. When Voyager 1 was launched, its ultimate destiny was to pierce this hull and sail into the unknown. The transition was modeled to be so subtle that engineers worried they might not even realize the exact moment the probe crossed the threshold. The onboard instruments designed to measure this transition are marvels of mid-20th century engineering. Stripped down to their most essential physics, there is the magnetometer, mounted at the end of a long, delicate boom to keep it isolated from the magnetic interference of the spacecraft's own electronics. It is designed to measure the invisible magnetic architecture of space, reading variations so microscopic they are equivalent to a fraction of a percent of Earth's magnetic field. Then there is the plasma wave subsystem, essentially a pair of incredibly sensitive electric antennas that listen to the electrostatic noise of charged particles interacting in the vacuum. It translates the silent, invisible dynamics of plasma into audible frequencies. It takes the temperature of the void. As Voyager 1 plunged deeper into the dark, approaching the distance of 10 billion miles from Earth, the data began to warp. The fundamental laws of the gradual fade, the soft merging of the river into the ocean, began to aggressively unravel. The telemetry filtering into the Jet Propulsion Laboratory started painting a picture of an environment that made no physical sense, according to every established model. As the solar wind slowed down at the edge of the heliosphere, the density of the plasma should have dropped to a near absolute zero. The temperature should have plummeted to the freezing baseline of deep space. But the instruments were screaming a different reality. Instead of smoothly dissipating, the solar wind was acting like a high-speed vehicle slamming into an invisible, immovable brick wall. The plasma wasn't fading, it was piling up, it was compressing, and in the strict laws of thermodynamics, when a gas or plasma is violently compressed, it heats up. The antennas of the plasma wave subsystem began to vibrate with intense, chaotic static. The magnetic field readings began to violently fluctuate, twisting and doubling back on themselves in a tangled, tortured mess of magnetic flux. The environment around the tiny, fragile probe was rapidly becoming more hostile, more energized, and fundamentally more chaotic than anything it had encountered during its flybys of the massive, turbulent gas giants. Voyager 1 was not sailing into a quiet, empty sea. It was sailing headlong into a compression zone of unfathomable proportions. The quiet fading out of the sun's influence was a naive mathematical fantasy. The reality was a brutal, relentless clash of two titanic cosmic forces fighting for dominance in the dark. The heliosphere was not gently giving way to the galaxy. It was violently resisting it, creating a volatile, superheated boundary layer that defied all conventional understanding of how empty space was supposed to behave. And as the probe pushed deeper into this turbulent boundary, the temperature readings from the plasma science instruments registered a spike that defied all logic, signaling that the true horror of the interstellar boundary was only just beginning to reveal itself. To comprehend the data that began bleeding onto the monitors at the Jet Propulsion Laboratory, you must first confront the sheer, agonizing scale of the architecture we are dealing with. In astrophysics, we use a standard unit of measurement called the astronomical unit. 1 astronomical unit represents the average distance from the Earth to the Sun, roughly 93 million miles. It is a distance so vast that light itself, traveling at the absolute speed limit of the universe, takes over 8 minutes to cross it. At the time the anomaly was registered, Voyager 1 was pushing past 120 astronomical units. It is incredibly difficult for the human mind to process a number that large without rendering it meaningless. Imagine standing at the edge of the Pacific Ocean trying to pilot a fragile, remote-controlled submarine navigating the crushing depths of the Mariana Trench, but your only connection is a single, fraying wire, and every command you send takes nearly an entire day to arrive. Now, imagine that the submarine is powered by a decaying, radioactive battery that is slowly dying, and the signal it sends back is so mathematically faint that it is equivalent to the energy of a refrigerator light bulb, viewed from across a continent. That is the reality of communicating with Voyager 1. Its main transmitter operates on a mere 20 watts of power. By the time that signal crosses the 11 billion miles of dark space to reach Earth, the radio waves have spread out and lost so much energy that they arrive with a power measured in fractions of a billionth of a watt. To even catch this dying whisper, we rely on the Deep Space Network. These are not standard antennas. They are monstrous, hypersensitive, parabolic dishes, some measuring 70 meters across, situated in California, Spain, and Australia. They must maintain a continuous, perfectly synchronized rotation with the Earth, staring unblinkingly into a specific microscopic patch of the deep sky, utilizing receivers cooled by liquid helium to absolute zero just to filter out the background microwave radiation of the universe. And what this monumental feat of planetary engineering heard whispering back from the dark was a physical impossibility. As Voyager 1 crossed the boundary known as the termination shock, the environment violently changed. For billions of miles, the solar wind had been traveling at supersonic speeds, a relentless million-mile-per-hour outward gale. But as it collided with the mounting pressure of the interstellar medium, this hypervelocity plasma was forced to brutally and abruptly slow down. In fluid dynamics, when a supersonic flow suddenly drops below the speed of sound, it creates a massive shock wave. This is the termination shock. It is the cosmic equivalent of water crashing at the base of a towering waterfall, churning into a chaotic, turbulent froth. Beyond this shockwave lies the heliosheath, the outer rim of our solar system's protective bubble. It was here that the baseline predictions of a quiet, freezing void entirely collapsed. The data indicated that Voyager 1 had entered a sprawling, boiling ocean of compressed radiation. The temperatures recorded in this region did not drop toward absolute zero. They skyrocketed. The thermal readings of the plasma surged to an incomprehensible 30,000 to 50,000 degrees Fahrenheit. This is what we refer to as the wall of fire. At first glance, this concept shatters our everyday intuition. If a fragile aluminum probe built in the 1970s flew into an environment burning at 50,000 degrees, it should have been instantly incinerated. It should have melted into slag and vaporized within fractions of a second. Yet, Voyager 1 continued to transmit entirely physically unharmed. To understand why, we must decouple two concepts that are permanently linked in our terrestrial experience: heat and temperature. On Earth, in a dense atmosphere, they feel like the exact same thing, but in the vacuum of deep space, they are entirely different mechanical properties. Temperature is simply a measurement of speed. It is the kinetic energy of individual atoms and molecules. The faster they move, the higher the temperature. Heat, however, is a measurement of energy transfer. It requires density. It requires mass. Imagine you are standing in a colossal, pitch-black cathedral that has been supercooled to freezing temperatures. If someone fires a single microscopic bullet through the room at 10,000 miles an hour, that bullet possesses a tremendously high temperature due to its kinetic velocity. But if that solitary bullet strikes you, while it will cause microscopic damage, it does not contain enough total thermal mass to warm your body or heat the freezing room. The wall of fire at the edge of the solar system operates on this exact, terrifying principle. The plasma out there is unimaginably sparse. You could sweep a net the size of a mountain through the heliosheath and only catch a handful of protons. But those few protons have been violently compressed, agitated, and accelerated by the collision of two galactic forces. They are vibrating and ricocheting at staggering velocities, registering as tens of thousands of degrees. Voyager 1 was flying through an invisible inferno, bombarded by hyper-accelerated atomic fire. But because the void is so unfathomably empty, there was not enough physical matter to transfer that heat to the hull of the spacecraft. It was simultaneously freezing to death in the darkest depths of space while navigating a hurricane of boiling atomic fire. But the instruments were not just registering temperature, they were measuring the architecture of the void itself. One of the most critical pieces of hardware on Voyager 1 is the low-energy charged particle instrument, designed by the brilliant physicist Stamatios Kremikas. It is a masterpiece of mechanical endurance. To measure the direction of the solar wind, the sensor cannot remain stationary. It must physically look around. It does this using a stepping motor, rotating the sensor incrementally to sweep a 360-degree view of the environment. For decades, through the absolute cold of deep space, without any possibility of lubrication, this small mechanical motor has clicked and rotated millions of times, faithfully mapping the outward push of our sun. As Voyager traveled deeper into the heliosheath, this resilient instrument reported something chilling: the outward million-mile-per-hour gale of the solar wind. The breath of our star that had propelled us, sheltered us, and pushed outward for billions of years began to fail. The wind didn't just slow down, it began to turn sideways. As the pressure of the interstellar galaxy mounted against the heliosphere, the solar particles could no longer push forward. They were hitting a barrier of unimaginable resistance. Unable to penetrate the interstellar medium, the highly charged particles of the solar wind were forced to deflect, sliding laterally along the inside of the boundary, like a river hitting a solid concrete dam and bleeding off into a swamp. This created a staggering phenomenon known as the stagnation region, a vast, eerie zone of cosmic doldrums where the outward velocity of the solar system officially drops to zero. The pressure here is suffocating. The plasma is trapped, endlessly churning, unable to go forward into the galaxy, and unable to return to the sun. It is a stagnant, radioactive graveyard of solar material piling up against the dark. We did not rely entirely on the lonely telemetry of Voyager to understand this. While the probe was physically cutting through the dark, scientists back on Earth engineered a way to map this invisible wall from afar. In 2008, NASA launched the Interstellar Boundary Explorer, or IBEX. It was placed into orbit around the Earth with a very specific, ghostly mission. It was not designed to look at stars or planets. It was designed to look at shadows. IBEX maps energetic neutral atoms. This requires a deep dive into the microscopic violence of the boundary. When a electrically charged proton from the solar wind reaches the edge of the heliosphere, it crashes into the slow, heavy, neutral atoms of hydrogen drifting in from the interstellar void. In the chaos of this collision, a bizarre atomic theft occurs. The solar proton rips an electron away from the interstellar atom. In an instant, the solar proton becomes electrically neutral. Because it no longer has an electrical charge, it is instantly freed from the magnetic constraints of the solar system's magnetic field. It becomes a ghost, ignoring all magnetic boundaries, and shoots off in a straight line at phenomenal speeds. Some of these newly formed neutral atoms shoot straight back toward the inner solar system. IBEX was designed to catch these exact atoms. By mapping where these hypervelocity ghosts were coming from, scientists were able to create the first physical map of the invisible wall Voyager was navigating. And what they found broke their models again. They did not find a uniform, spherical bubble. IBEX detected a colossal, glowing ribbon of intense energy wrapped entirely around the outer edge of the solar system. A permanent, highly pressurized scar in the fabric of space where the magnetic field of the galaxy was physically pressing against the heliosphere, forcing the plasma to pile up and detonate in a continuous, invisible ring of fire. Voyager 1 was sailing directly toward the densest, most violent section of this ribbon. As the outward velocity of the wind dropped to absolute zero, the mathematical equations governing the magnetic field began to predict an impending structural failure. The magnetic field of the Sun is not a simple, static bar magnet. Because the Sun rotates, dragging its plasma with it, the magnetic field lines are spun out into a massive, rotating, three-dimensional spiral known as the Parker spiral. It acts like an infinitely expanding watch spring, winding tighter and tighter as it stretches out into the darkness. Inside the stagnation region, where the solar wind has stopped moving, this magnetic spring is still being forcibly wound by the distant rotation of the Sun, but it has nowhere left to expand. The magnetic field lines begin to compress. They pile up against each other, jamming together in an increasingly tight, volatile configuration. The magnetic pressure inside this zone began to spike exponentially. It is the mechanical equivalent of placing a steel strut into a hydraulic press. You can watch the pressure gauge climb. You can see the microscopic stress fractures forming in the metal. You know that at some point, the fundamental atomic structure of the material must fail. The physicists monitoring the magnetometer data watched this cosmic pressure mount for months. The intensity of the magnetic field was doubling, tripling, twisting into a tortured, chaotic geometry. The heliosphere was violently fighting to maintain its structural integrity against the immense, crushing weight of the interstellar void. But the void is relentless. The galaxy does not care about the fragile bubble of a single, unremarkable yellow dwarf star. Deep within this mounting pressure, a new, entirely alien data set began to slowly filter through the static. The low-energy charged particle instrument, still faithfully rotating in the freezing dark, began to detect a subtle contamination in the environment. It was registering a steady, creeping increase in particles that did not originate from our sun. These were galactic cosmic rays, heavy, hyperaccelerated ions, born in the catastrophic supernova of dying stars thousands of light-years away. For billions of years, the intense outward pressure of the heliosphere has acted as an impenetrable shield, deflecting these lethal interstellar bullets, preventing them from flooding the inner solar system and sterilizing our world. But now, in the dense, superheated, mathematically impossible environment of the stagnation region, the levels of these high-energy galactic rays were beginning to slowly, inexorably rise. The shielding was failing. The pressure of the magnetic field had reached an unsustainable threshold. The architecture of the solar system was being crushed, and then the magnetometer registered a sudden, massive shift in the magnetic flux. A reading so bizarre and counterintuitive that it forced the entire astrophysical community to question whether we actually understood the fundamental laws of interstellar space at all. To declare that humanity has officially left its home star, the scientific orthodoxy of astrophysics demanded 3 irrefutable pillars of evidence. These were not casual guidelines, but absolute mathematical signatures that would prove, beyond any shadow of a doubt, that Voyager 1 had pierced the final membrane of the heliosphere and entered the raw, unfiltered environment of the interstellar medium. The community of physicists had spent decades building their models upon these 3 distinct rules, confident that the architecture of deep space would obey their logical predictions. First, the heliospheric particles had to vanish. The steady, outward flow of low-energy protons exhaled by our sun, which had relentlessly bombarded the spacecraft for 35 years, needed to drop to absolute zero. Second, the galactic cosmic rays had to surge. The high-energy atomic shrapnel from ancient, distant supernova, normally repelled by the immense pressure of the solar wind, needed to permanently flood the sensors, confirming that the protective shield of our solar system had finally been breached. Third, and arguably the most critical requirement of all, the fundamental architecture of the magnetic field had to completely and violently restructure itself. For billions of miles, the sun's magnetic field lines had dictated the orientation of space, wrapping around the entire solar system in an ever-expanding horizontal spiral. But the magnetic field of the Milky Way galaxy operates on an entirely different, independent axis. It is not anchored to our sun. It sweeps through the interstellar void at a sharp, distinct angle, driven by the massive, churning galactic core. Therefore, the absolute proof of leaving the solar system rested on the magnetometer. The moment Voyager 1 crossed the heliopause, the instrument was supposed to register an abrupt, undeniable shift in the magnetic vector. The cosmic compass needle of the spacecraft had to dramatically swing away from the sun's influence and align itself with the distant, crushing tides of the galaxy. This was the undisputed consensus. It was the physical threshold that the brilliant minds at the Jet Propulsion Laboratory had been anticipating for an entire generation. But the universe, in its vast and indifferent complexity, does not care about terrestrial mathematics. As the summer of 2012 approached, The data trickling back through the deep space network began to paint a picture of an environment descending into total structural chaos. On July 28th, Voyager 1 experienced an event that defied every simulation ever run on Earth. The outward pressure of the solar wind did not just gradually fade, as earlier models had optimistically predicted. Instead, it collapsed. Over the course of a few tense, agonizing days, the level of solar particles plummeted by a staggering factor of 1,000. It was as if a massive, invisible switch had been thrown in the dark, or as if the spacecraft had suddenly flown out of a thick, suffocating fog into a terrifying, empty clarity. Simultaneously, the secondary sensors on the low-energy charged particle instrument began screaming. The lethal, high-velocity galactic cosmic rays, the deadly radiation of the interstellar void, spiked massively. They flooded the delicate inner workings of the probe, washing over the radioactive core and the fragile circuitry with the unfiltered fury of 1,000 dead stars. For a brief, electrifying moment, the analysts observing the telemetry believed the ultimate milestone had been achieved. The first two conditions had been met with a violent, undeniable clarity. The solar wind was gone. The galactic radiation had arrived. By all logical reasoning, humanity had just touched the interstellar void. The champagne was metaphorically poured. The press releases were tentatively drafted. All that remained was for the magnetometer data to slowly transmit back to Earth, confirming the final, crucial piece of the puzzle, the shifting of the magnetic field. But when the magnetic telemetry finally whispered through the gargantuan listening dishes on Earth, the celebration abruptly died in a suffocating silence of confusion. The magnetic field had not shifted. The intensity of the magnetic pressure had violently spiked, verifying that Voyager 1 was pushing through the superheated compression zone, the invisible wall of fire where the solar system was brutally slamming against the interstellar medium. The magnetic flux was incredibly dense, tightly packed, and groaning under immense cosmic strain, but the direction of the field lines remained perfectly, stubbornly anchored to the sun. The vector had not rotated a single degree toward the galactic orientation. It was a staggering, agonizing physical contradiction. It was the scientific equivalent of stepping out of your heavily fortified home into a raging, freezing blizzard, feeling the lethal chill of the wind and the snow burying your feet, only to look up and realize the ceiling of your living room is still floating directly above your head. You are simultaneously inside and outside. You are standing in a physical paradox. How could the spacecraft be submerged in the radiation of the deep galaxy, yet still be entirely bound by the magnetic architecture of our sun? For months, this irreconcilable discrepancy paralyzed the astrophysical community. The project scientist, Dr. Ed Stone, a man who had fiercely guided the Voyager mission since its inception in 1972, refused to officially declare that the spacecraft had left the solar system. The orthodoxy of the magnetic field was too fundamental to ignore. A bitter, highly technical debate ignited across scientific journals and closed-door meetings. Some argued that the magnetometer, after 35 years in the freezing, irradiated vacuum, was finally failing. Others argued that the fundamental equations governing fluid dynamics and plasma physics in deep space were entirely wrong. As August bled into September, the anomaly only deepened. The spacecraft did not simply cross a solid line. It began to drift in and out of different, impossible realities. The data showed the boundary of the solar system washing back and forth over the tiny probe like a massive, breathing cosmic tide. The solar particles would suddenly vanish, the galactic rays would spike, and then, days later, the environment would violently revert. The sun's plasma would flood back in, and the cosmic rays would be pushed away. It was a chaotic, violent dance at the edge of the abyss, proving that the heliopause was not a rigid wall of glass, but a highly volatile, fluctuating membrane. Yet, through all of this violent shifting, the magnetic field remained eerily, terrifyingly locked in place. The wall of fire was roaring with 50,000-degree plasma. The radiation of dead stars was flooding the void, but the magnetic structure remained in a state of unnatural, silent tension. To resolve this impossible paradox, theoretical physicists had to abandon decades of established models and look toward a phenomenon so complex and destructive that it is incredibly difficult to replicate outside of a supercomputer. They had to introduce the terrifying mechanics of magnetic reconnection. To visualize this, you must abandon the idea of magnetic fields as simple, invisible lines drawn on a chalkboard. In the hyper-pressurized, superheated environment of the heliosheath, magnetic fields act like massive, physical cables of immense tension. Imagine a colossal suspension bridge spanning the dark, where millions of steel cables are stretched to their absolute breaking point. Now imagine an opposing suspension bridge built by the galaxy, pushing directly against it. As the relentless pressure of the interstellar medium crushes against the outer boundary of the heliosphere, the magnetic cables of the Sun and the magnetic cables of the galaxy are forced together. They are squeezed so violently that the structural integrity of the magnetic flux cannot hold. The immense tension causes the fields to literally snap. When they break, they violently reweave and fuse with each other, creating an explosive release of kinetic energy and heat. This process of snapping and reconnecting is what fundamentally fuels the scorching temperatures of the wall of fire. But the true horror of this mechanism lies in what is created after the cables fuse. When the closed magnetic loops of our solar system snap and reconnect with the open magnetic lines of the interstellar void, they create something the scientists termed the magnetic highway. The heliopause was never a solid barrier. It is a highly porous, fractured, and chaotic frontier composed of massive, interconnected magnetic tubes. These flux tubes act like highly pressurized, frictionless superhighways, directly linking the inner solar system to the deep, uncharted galaxy. This terrifying realization finally explained the impossible data. When Voyager 1 experienced the sudden, brutal drop in solar particles, it had not crossed out into the pristine interstellar medium. It had stumbled into one of these massive magnetic tubes because the tube was directly connected to the outside galaxy. The highly pressurized solar particles instantly vented out into the deep void, draining away at near light speed, exactly like the air rushing out of an explosively depressurized airplane cabin. And through that exact same tube, the heavy, lethal, galactic cosmic rays flooded inside, pouring down the magnetic highway and drowning the spacecraft in interstellar radiation. Voyager 1 was sitting inside a fractured pipeline. It was tasting the raw, unfiltered environment of the deep galaxy. But because the tube itself was still originally formed from the sun's magnetic field lines, the magnetometer continued to read the solar orientation. The probe was trapped in a cosmic purgatory, standing in the doorway between two titanic forces, enveloped in a structural silence that masked an invisible, roaring current of radioactive death. This revelation shattered the comforting illusion of a neat, orderly universe. The boundary protecting humanity from the violent, decaying ruins of the Milky Way is not a smooth, impenetrable shield. It is a bleeding, fractured membrane. It is actively tearing open and stitching itself back together in a perpetual, superheated agony. The heliopause is a dynamic, hostile environment where the very fabric of magnetic reality is constantly being stretched, snapped, and violently reconfigured. And, as the data from this magnetic highway continued to pour into the deep space network, a much darker, far more unsettling realization began to take hold among the analysts. If the edge of our solar system is not a serene, quiet fade into the dark, but a violently contested, superheated war zone of snapping magnetic flux, then our entire understanding of the interstellar medium, the vast, unfathomable ocean that stretches between the stars, must be fundamentally flawed. We had assumed the void was empty. We had assumed it was cold. We had assumed that the space beyond our sun's influence was a frictionless, predictable vacuum where the laws of physics operated with a clean, mathematical elegance. But the reality of the magnetic highway and the wall of fire proved that the deep dark is incredibly dense with hidden, destructive mechanics. The plasma is alive. The magnetic fields are highly pressurized, hostile architecture. The terrifying reality was not just that our terrestrial models had failed, but that the boundary between our isolated world and the infinite galaxy was operating under an entirely alien set of physical laws, harboring a mechanism so profound and relentlessly unforgiving that it threatened to fundamentally rewrite our understanding of how anything survives out there in the absolute dark. The revelation of the magnetic highway is not merely a fascinating mechanical anomaly for astrophysicists to debate in the sterile halls of academia. It is a fundamental, terrifying paradigm shift in how we must view our place in the cosmic architecture. The realization that the boundary of our solar system is a violently contested, superheated war zone of snapping magnetic cables completely shatters the deeply ingrained human illusion of an empty, peaceful void. For generations, we have looked up at the black canvas between the stars and assumed it was a frictionless, predictable vacuum, a quiet, empty highway waiting for us to build the right engine, the right propulsion system to simply accelerate across the gap. We thought of our solar system as an isolated island in a calm, dark sea. The data retrieved from the bleeding edge of the heliopause proves that this assumption is a lethal fantasy. The space between the stars is not empty. It is a highly pressurized, aggressively fluid environment. The Milky Way galaxy possesses its own chaotic, relentless weather system, operating on a scale so massive it renders human comprehension completely obsolete. Our sun, along with all the planets tethered to its gravitational pull, is not stationary. We are hurtling around the supermassive black hole at the center of the galaxy at an agonizing speed of 500,000 miles per hour. As we blindly plow through the interstellar medium, our heliosphere acts like the bow of a ship crashing into an oncoming current. Because we are moving so rapidly, the protective bubble around our solar system is not a perfect, elegant sphere. The crushing friction of the interstellar wind distorts it. It compresses the front into a blunt, heavily reinforced nose, the exact region where Voyager 1 is currently enduring the wall of fire, while the back is violently dragged out into a massive, turbulent tail, stretching for hundreds of billions of miles into our cosmic wake. We are a solitary submarine, desperately maintaining pressure as we navigate a dark, highly acidic ocean choked with the heavy, radioactive shrapnel of dead stars. And right now, our solar system is sailing through a particularly treacherous region of this ocean. Astrophysicists refer to it as the local interstellar cloud, a sprawling, tenuous expanse of hyperheated plasma and dust, roughly 30 light-years across. It is the lingering, expanding ghost of an ancient supernova cluster. The intense outward pressure of our sun's solar wind is the only thing keeping this radioactive fog from collapsing inward and drowning the inner planets. The wall of fire, the violent magnetic reconnection zones, the sudden flooding of galactic cosmic rays are not just scientific curiosities, they are the active, physical mechanics of our survival. They are the sound of the submarine's hull groaning under the immense, crushing pressure of the deep. This forces a harrowing question about the long-term future of our species. If the very edge of our own star system is an intensely magnetized, superheated gauntlet of lethal radiation, what does that mean for the dream of interstellar travel? The concept of human beings one day leaving the solar system in massive generation ships has always been the ultimate, optimistic endgame of our civilization. But the telemetry from Voyager implies that any vessel attempting to cross the heliopause will not just be drifting into a quiet, dark, it will have to physically punch through a boiling compression zone, navigate the chaotic, snapping magnetic flux of the highway, and then endure the unfiltered, raw fury of the galactic wind for thousands of years. The interstellar medium is not a vacuum waiting to be explored. It is a violently hostile territory that actively repels biological life. But the physical hostility of the plasma wall is only the first of the hidden consequences. The second is the agonizing, crushing reality of cosmic scale and time. The public consciousness operates under a comforting, simplified illusion. When the press releases were finally drafted and the headlines enthusiastically declared that Voyager 1 had officially left the solar system, it was, in reality, a technical half-truth. It had pierced the magnetic boundary. It had escaped the jurisdiction of the solar wind, but the sun exercises a power far older, far deeper, and its reach extends incomprehensibly farther than the heliopause. Beyond the wall of fire, beyond the turbulent magnetic superhighways, lies a structure so vast it defies the architecture of human thought, the Oort cloud. It is a spherical, ghostly shell enveloping our entire solar system, composed of trillions of jagged, frozen comets and ancient, icy debris left over from the violent birth of the planets 4.5 billion years ago. These objects are so distant, so profoundly isolated from the warmth of the inner system, that they drift in a state of near absolute zero, barely held in orbit by the faintest, most microscopic whisper of the sun's gravitational pull. To understand the true scale of the prison we exist in, you must look at the mathematics of eternity. Voyager 1 is currently traveling outward at 38,000 miles per hour. It covers roughly 1,000,000 miles a day at this blistering, relentless velocity. It will take the spacecraft another 300 years just to reach the inner edge of the Oort cloud. 3 centuries just to touch the perimeter of the final graveyard. And once it enters that freezing expanse of suspended ice and stone, it will take the probe an estimated 30,000 years to cross to the other side. 30 millennia to finally, truly escape the gravitational anchor of our sun and drift freely into the open galaxy. To put that timescale into perspective, the entirety of recorded human civilization, from the construction of the first ziggurats in Mesopotamia, through the rise and fall of every empire, every war, every scientific revolution, up to the exact moment you are listening to this, has occurred within the span of roughly 5,000 years. Voyager's journey through the outer darkness will take 6 times the entire history of human civilization. We are forced to confront the chilling latency of our own footprint in the universe. We are not conquering the stars. We are throwing a tiny, fragile bottle into an infinitely massive ocean, hoping it doesn't immediately dissolve in the acid, and the bottle is already dying. The radioactive heartbeat of the spacecraft is governed by the cold, unforgiving mathematics of half-lives. Deep within the probe's aluminum chassis, a sphere of plutonium-238 is quietly decaying. It sheds subatomic particles, generating the fractional amount of thermal energy required to keep the delicate circuitry from freezing solid in the abyssal temperatures. But this decay is finite. It is a dying ember in a drafty, infinitely large room. Year by year, watt by watt, the power output drops. The engineers back on Earth have been forced into a grim, agonizing routine of orbital triage. To keep the core systems alive, they have been systematically amputating the probe's senses, shutting down the cameras, powering off the heaters, killing the redundant science instruments one by one. They are sending desperate radio commands across billions of miles of dark space to slowly execute pieces of their own creation, sacrificing the limbs to protect the brain, just to buy a few more months of telemetry from the abyss. Within the next decade, the plutonium will cross a critical threshold. There will no longer be enough heat to keep the hydrazine propellant lines from freezing. There will no longer be enough power to spin the gyroscopes or aim the faint radio transmitter back toward the microscopic pale blue dot of Earth. The instruments will flatline. The long, drawn-out conversation between humanity and its furthest emissary will simply stop. When that happens, Voyager 1 will not cease to exist. It will merely transition from a scientific vessel into a dead, silent monument, a frozen ghost ship, blind and deaf, plummeting endlessly outward into the crushing dark. Attached to the side of this dying machine is the golden record, a 12-inch phonograph disc, forged of copper and plated in gold. It contains the encoded sounds of thunder, of birds, of a mother kissing her child, the music of Bach and Chuck Berry, and greetings spoken in 55 human languages. It was intended as a message in a bottle for any intelligence that might stumble upon it in the deep future. A desperate, beautiful plea for connection. A physical proof that we existed, that we thought, and that we reached out into the dark. But the environment, the probe, has just entered the violent, highly pressurized interstellar mediums, actively hostile to preservation. The galactic cosmic rays, the hyper-accelerated atomic shrapnel that flooded the probe when the magnetic cables snapped at the boundary, do not just pass through the ship harmlessly. They strike the gold. At a microscopic level, atom by atom, the intense radiation of the deep void is slowly sandblasting the record. Millions of years from now, long after the sun has expanded and swallowed the earth, long after every trace of our civilization has been reduced to ash and swallowed by geologic time, Voyager will still be drifting, but the physical hostility of the galaxy will have slowly eroded the grooves of the record. The music, the voices, the mathematical maps of our location, everything we tried to preserve, will be slowly, violently scrubbed clean by the abrasive friction of the cosmos. We sent a piece of our soul into the dark, only to discover that the dark is not an empty canvas waiting for our signature. It is a churning, violent mechanism that will eventually grind everything we have ever been into invisible, radioactive dust. The boundary we crossed was not a gateway to the stars. It was a mirror reflecting back the terrifying, inescapable reality of our own overwhelming fragility. We built a machine powered by the decaying embers of a dead element and hurled it into the absolute dark. We did this because our species is driven by a desperate, arrogant need to be known. We have an intrinsic desire to leave a permanent mark on a reality that we fundamentally do not understand. For centuries, we looked up at the night sky and projected our own terrestrial ego onto the stars. We imagined a grand, empty theater waiting for our eventual arrival. We believed the cosmos was a passive canvas, a silent, frictionless expanse where human ingenuity would inevitably triumph over the vastness of distance and time. The telemetry from the very edge of our solar system has stripped that comforting delusion away, replacing it with a reality that is violently sobering. The boundary of our sun's influence is not a serene, poetic threshold. It is a chaotic, tearing, magnetic membrane. It is a superheated scar of compressed plasma that barely holds back the crushing, radioactive ruins of the Milky Way. When you comprehend the physical violence of the wall of fire, the sheer, unimaginable scale of the magnetic superhaze, and the lethal friction of the interstellar medium, a chilling truth begins to crystallize. The universe is not an empty, waiting frontier. It is a fiercely active, hostile architecture. It is a colossal, grinding mechanism of thermodynamics and gravity that operates with an absolute, terrifying indifference to biological life. The galaxy does not care about the golden record bolted to the side of that fragile aluminum frame. It does not care about the music of Bach, or the mathematical diagrams, or the desperate greetings spoken in 55 fading human languages. The heavy cosmic rays currently sandblasting the hull of our furthest emissary are not acting out of malice. They are simply obeying the blind, mechanical laws of an environment that naturally erases everything. Within a few short years, the last fractions of heat from the plutonium core will dissipate. The fuel lines will freeze solid. The fragile transmitters that have faithfully whispered across billions of miles of space will drop below the threshold of detection, going permanently dark. Voyager 1 will become a blind, deaf, and silent ghost. It will tumble helplessly out into the black, taking 30,000 years just to drift through the frozen, suspended comets of the Oort cloud. It will sail onward for billions of years, a dead monument to a species that was trapped on a microscopic, pale blue rock, entirely surrounded by an ocean of fire, radiation, and crushing pressure. We are an anomaly, a brief, localized chemical reaction occurring deep inside a temporary magnetic shield. Every human triumph, every philosophical revelation, every war, and every scientific milestone we have ever achieved is entirely contained within a fragile, groaning bubble that is currently being relentlessly crushed by the immense weight of the interstellar void. There is no welcoming dawn waiting for us beyond the heliopause. There is no quiet, peaceful ocean to sail. There is only the violent friction of dead stars, the twisting of magnetic flux, and the endless, suffocating dark. We are entirely alone in the abyss, watching the only true emissary we ever managed to push through the boundary slowly fade into an irreversible, absolute silence.